Thank you for having me here. And thank you for the former great speech from two researchers. And I'm going to a little bit about the policy measures and the remaining like issues to control PM further reductions in Korea. Yeah, the Korean, I'm going to only focus on PM 2.5. As former speaker said, majority of the Korean PM problem is from the secondary erosion formation. And as I show here, the overall national average of PM 2.5 is was about 25 microgram per cubic meter. And it was a little bit stagnant, a little bit of a few years. And see the 2020, the PM 2.5 level is below 20. So as Dr. Chang said, there's some probably effectiveness of the national policy measures to control the PM 2.5 emissions. But as you can see the right figure, there was, as you know, the COVID-19 happening last year. And 2020, February, March, there was a huge lockdown in China and also a great, strong social distancing in South Korea as well. So the yellow sticks shows the PM 2.5 concentration in 2019. And as you see the 2020, the blue line, the February and March, the PM 2.5 in Seoul has greatly reduced. So that may be affect the great reduction of national average PM 2.5 below 20. So as Dr. Zhang said, we believe that the policy may affect a very positive result for the PM 2.5 concentration, but still we need to monitor the PM 2.5 and see what's going to happen this year and next year. And as you see, the Korea's characteristic of PM 2.5 concentration had large seasonal variation. As you see, from the winter season, we have sometimes more than 30 microgram per cubic meter, but in summertime is almost below 20. So this is a very like a clear characteristics of Korea. So that's why we need a seasonal control air quality plan. So after about 2015, we have a great improvement of policy measures. Even though we only start the measurement and control PM 2.5 was a little bit late. Only 2015, we start to measure the nationwide measure of 2.5, but our policy is getting very being strengthened. And 2018, the PM 2.5 national standard is strengthened to 15 microgram, which is almost same as US. And the emergency reduction measures is also invented, like during a severe PM 2.5 events, which is starting 2018. And we made a special law for PM control in 2019, which is we have a historic PM 2.5 pollution event. And that year, the government made a comprehensive plans for national PM mitigation, which is a 5-year plan start. And first, we consider the secondary PM productions. And first, we set up the target to mitigate PM precursors, NOx and SOx and other contributors. first time. It was late, but it was a good direction. And measures for seasonal pollution problems start in the winter time of 2019, which means December, I believe. And we, at this season, we have strong plan to reduce the power plant operation and also to strong plan for restriction of large emission vehicles. And furthermore, we used to control only the Seoul national area to control the total emissions, but we expand to designating the 4 more regions covering all the pollution areas in South Korea. And also the duties and responsibility also expand from only from the central government to local government. So we hope that this new direction of the Korean government may be effective sooner or later. This is also, I want to talk about the policy priorities in based on the science, which is based on our calculation of chemical and transport model. And I'm sorry for the characters in Korean, so it's very hard to read by foreign people. But as you can see, I don't have a pointer, but there's some northern side. We have a Seoul metropolitan area where we have almost half of the population and a lot of emission facilities. But we found that the Chungcheong area, the middle of the western area, has a lot of contributions of plants and also industries and also traffics and many diverse sources which contribute nationwide PM 2.5 formation, which is also include Daesan industry complex, which Dr. Crawford pointed out. So this area is one of the key areas we have to control in the future, near future, very quickly. And also, Seoul metro area is also still important because the half of the Korean population is there. So a lot of high pollution events exposed to the people, which is at like a health issue. So that must be a higher priority to control the PM 2.5 pollution. So also our calculation is that the bisectoral contribution is largely from the manufacturing industries and as mostly also as large as agricultural waste, which is from the livestock waste. And next is road vehicles and other transportation and power plants. So, and also we have to consider the population exposure to high PM 2.5 concentration. As you can see the left side next, so the left shows that the annual PM 2.5 concentration, and the left side is, you can see the western area is very high, relatively high PM 2.5 concentration, and we calculate the exposed people to the higher PM 2.5 concentration. Also, we calculate the vulnerable people younger than 18 and older than 65, and 1/3 population is exposed to the higher annual PM 2.5, like a 25 microgram per cubic meter. And the entire country, the vulnerable population is about 5.5 million. So that must be counted in our the policy. So I also want to talk about the ammonia production problems in Korea. And we have 75% of total domestic ammonia emissions from livestock waste, and that must be carefully counted. And also, we studied recently satellite observations of atmospheric ammonia, then make help the estimate ammonia emissions. And EANET site, 3 EANET sites in Korea, is now helping the long-term changes we figure out and we analyze the long-term changes in concentration and other data validation. So it is very useful. So we actually point out the China and Korea and Japan side, and there is some seasonal variation of ammonia, which is maximum in almost spring and summertime. But ammonium is different. This is one of the part of the PM.5, PM 2.5 like a product, so which is a different signal. So it's almost like contributions from the long range transport. So which is also useful to the local impact versus long range transport. So I wanna finally discuss the summary. Korea has enforced the PM control policies a little bit late since 2015, and now we are assessing the improvement. So probably the science and a lot of data and measurement can help to our achievement or other problems to figure out. And large population with relatively higher PM 2.5, effective management of almost 60,000 plants, manufacturing plants, and livestock waste are major challenges in Korea PM reduction policies. And ammonia is also one of the key species of PM pollution formations. And now EANET long-term measurement can contribute to assessing the long-term variation of domestic ammonia concentrations. Actually, some of the Korean sites, EANET site, Imsil and Jeju, which is a agricultural area, is the concentration of ammonia has been increased. It's very significant recently. So this is maybe a good topic to figure out what make this concentration and ammonia contribution is changed. And EANET measurements are used to validate also satellite ammonia product, which may be a very, I believe, useful for assessing ammonia emissions and identify the regional controllers of PM formation. Thank you.